This video is about measurement techniques and stoichiometry. If you can master the material in this video, you will understand dimensional analysis, one of the most important concepts in general chemistry. I know dimensional analysis is a scary word, but it doesn't have to be, if you understand what it is all about. Dimensional analysis is about converting units and problem solving. One of the most important things you will learn in general chemistry is that every number needs a unit. If I told you that I walked 5 today, what would that mean? Nothing to me. 5 feet, 5 miles, 5 meters. Every number needs a unit. Starting from the beginning, dimensional analysis is about multiplication and division of fractions and numbers. Starting with multiplication, we all know that 1 times 1 equals 1, and 2 times 1 equals 2. In fact, any number times 1 equals that number. In this scenario, n represents any real number. So now we know that any number times 1 equals that number. If you substitute for the 1 with 1 divided by 1 and multiply it by the n, it will still equal that same n. This is the first rule of dimensional analysis. 3.3 feet equals 1 meter. This is an example of a conversion factor. If you divide the 1 meter by itself, you will also have to divide the 3.3 feet by 1 meter as well. A second rule of dimensional analysis is that whatever you do to one side of an equality, you need to do to the other side of the equality also. So, the 1 meter over 1 meter is equivalent to the 1 divided by 1 times n that I told you about before. So the 3.3 feet over the 1 meter really equals 1. This is the definition of a conversion factor. It is a fraction that equals 1. If you don't know if it is a conversion factor, ask yourself this: is the top equivalent to the bottom? In this case, it is. 3.3 feet equals 1 meter. Since conversion factors equal 1, they can be inverted. This is the third rule of dimensional analysis. Dimensional analysis uses conversion factors to solve unit conversion problems, where we are trying to convert one unit into another. The hardest part of dimensional analysis is finding which conversion factor to use. So if you can figure that out, half the battle is already won. Another rule of dimensional analysis is to always put the desired unit on top of the conversion factor. So your initial unit is on the bottom of the conversion factor, and your desired unit is on the top of the conversion factor. Then your initial unit will cancel, and you will be left with your desired unit. So why and how is this useful? Converting units is an essential and critical skill in all STEM fields. STEM stands for science, technology, engineering, and mathematics. Chemistry is a science course, and all the skills you will learn in chemistry will help you in all of your other science classes. Don't believe me? Sit back and let me tell you a story then. The Mars Climate Orbiter was a 338 kilogram or 750 pound robotic space probe launched by NASA on December 11, 1998 to study the Martian climate, Martian atmosphere, and surface changes for a Martian year, 687 days. However, on September 23, 1999, communication with the spacecraft was lost because NASA's Mars Climate Orbiter engineers failed to make a simple conversion from English units to metric, an embarrassing lapse that sent the $125 million craft fatally close to the Martian surface, causing it to pass through the upper atmosphere and disintegrate. The issue was with the contractor Lockheed Martin, who did not use the commonly used metric units of newtons, and instead used the English units of pounds. This caused the orbiter, instead of finishing its trajectory at a safe 226 meters above the Mars surface, it finished its trajectory a fatal 57 meters above Mars' surface. So you see, units do matter. $125 million is a lot to lose because of a simple conversion factor problem. So now some practice problems. First, convert 25 kilograms to pounds. Remember our rules of dimensional analysis. The unit to be converted is on top. The conversion factor you will need to solve this problem is that 1 kilogram equals 2.2 pounds. One other rule with dimensional analysis is always write down what you are given first in this case 25 kilograms. Then put the unit you want to cancel on the bottom, kilograms, and put your desired unit on top, pounds. Remember, this is a conversion factor, and it must be equivalent or equal 1. The conversion factor in this case is that 2.2 pounds equals 1 kilogram. And then your kilograms will cancel out. To enter into your calculator, you need to type 25 times 2.2 to get the answer of 55. Why did I not type in the ones into my calculator? Because I remember my first rule of dimensional analysis, which means anything times 1 or divided by 1 equals itself. So therefore the answer is 55 pounds. Another more complicated practice problem, convert 55 miles per hour to meters per second. Remember again our unit conversion guide. Write down your desired unit on top of the conversion factor. The conversion you will need here is that 1 mile equals 1.6 kilometers. First, write down what you are given, 55 miles per hour, and then concentrate on the top part of the unit first, the miles to meters conversion. First, convert to kilometers by writing the kilometers on top. Even though this isn't the desired unit, it is still one step closer to finding our desired unit. And then your miles will cancel out. To convert kilometers to meters, remember that metric units are related to each other in very predictable ways. So therefore 1 kilometer equals 1,000 meters, because kilo means 1,000. And then your kilometers cancel out and you are left with your desired unit of meters. Now on to the bottom of our unit conversion problem, the hours to seconds. Well, you know that 60 minutes are in an hour, and then your hours cancel out. 60 seconds are in a minute, and your minutes cancel out. And you are left with your desired unit of seconds. Now you may be wondering why the desired unit in this case, the seconds, was written on the bottom of the conversion factor. Because this is where the seconds go in the unit. On your calculator, you need to type 55 times 1.6 times 1,000, all divided by 60 times 60, which equals 24.14. So therefore, the answer is 24 meters per second.